worship in lesson 5.1 today, our learning goal is that you can set up a system of equations to problem solve. So you have to set up your own system of equations and then solve it by graphing like we have been doing. The only difference is today I will not make you do check problems for them, because if you set up the wrong system of equations, your answer will probably check out in your system of equations, and then you'll be like, well, it worked, I checked it out, I got the right answer, but yet you didn't have the right equations to start with because you had to write your own. Okay, so we have to be really careful. That's going to be huge, making sure that we can set up our own system of equations properly. And this is challenging for students, so you need to be tuned in here. Okay? So, questions. How can you use a table to solve a system of equations, and how does the graph verify it? Well, we're going to use a table in the sense that what we're going to do is we're going to write an equation first of all, and then we're going to fill out a table. We're going to get some ordinance. Instead of graphing from slope-intercept form, we're going to review how do you graph using a table. Okay? So we have Bill and his brother who are collecting comic books. So here's where I'm at, right here. Okay, be with me. Bill and his brother collect comic books. Bill currently has 15 books and adds 2 books to his collection every month. Currently has 15 books and adds 2 to his collection every month. His brother currently has 7 books, and how many is he adding every month, Calvin? 4, yeah. He's adding 4 every month. So he starts with less, but he's adding more each month. So we're supposed to write equations below. I give us a spot to do it at, to find the number of months. You know what? Let's underline that right here because I'm giving you some pretty important information right there. Number of months is going to be represented by x. So the number of months in our equation is going to be our x value. So we're supposed to find the number of months after which Bill and his brother will have the same number of books. And the number of books, don't underline same, underline number of books is going to be our y value. So y is going to represent how many books they have, each of them. What's their total number of books? But we're eventually going to find out after how many months would they have the same. Would it be after the first month, the 3rd month, the 10th month? When will that actually be? So given that y is going to be the total number of books each of them have, they're each going to have their own equation. And x being the number of months that they're collecting these comic books, what do you think could be an equation we could use for Bill? It says number of comic books in Bill's collection. That's where we're going to write an equation. Anybody have any suggestions what they think we could use? I don't think your calculator is going to help us find this right now. I want an equation right now. What do you think could be an equation? You may want to take a stab at it, Aurora? Yeah, for Bill. 15 plus 2 times x. Okay, 15 plus 2 times x equals y. What do you think, class? Think that would work? So the total number of books y that Bill has can be found. It is equal to, take 2 times the number of months that he is collecting and add 15 to that because why? Yeah, currently he's starting with 15, isn't he? Yeah, this is a good equation. If you like it better in this format, y equals 2x plus 15, can we write it like that? Is that okay? Can we rearrange it like that? Yeah. Okay. Well, now I want you on your own paper with your pencil to write an equation for his brother's collection. What equation could represent the brother's total number of books after a given number of months? Okay, who's willing to share their equation? Joss? Y equals 4x plus 7. How many of you have the same equation Joss has? That would be a good equation. It says the total number of books the brother is going to have is equal to, take 4 times the number of months because he's going to add 4 more every month, and add 7 to it because apparently he started with 7, right? Okay, 2 good equations. Okay, so we have now set up our own system of equations. We have really done this right here. We have said we have y equals 2x plus 15 and y equals 4x plus 7. We've set up our own to problem solve. In other words, the solution we get is going to give us some information this time. We know what that solution is going to be telling us. So let's do it by making a table. Okay, let's use the table to do it. So let's do Bill here and the brother here. Let's see if we can see where it's going to happen in the table. So y equals 2x plus 15, that's Bill's, and y equals 4x plus 7 is the brother. So we're going to substitute in 0. So let's just, we have 2 times 0 plus 15. Well, 2 times 0 is? 0. And plus 15 is? 15. And in other words, when no time has gone by yet, at the start there are 15 bucks. Well, does that make sense? Yeah, that's our y-intercept, isn't it? So 4 times 0 for the brother plus 7. What's that equal? 7. Okay. Go ahead and complete that table, because I know you can. Substitute in your given x values and do the multiplying, then the adding, and get your y value, how many books they will each have after that amount of time. You know what, if you haven't gone too crazy yet, you're starting, I'm guessing by now you're starting to see a pattern. And you're like, this is a whole lot of lead getting put down for what's happening. What's happening in Bill's column? Going up by 2s. You know what? I'm going to start being lazy. And I'm going to let you too, if you want to. What's happening in the brother's column? Going up by 4s. After we're pretty convinced that that's what's happening, we can say, you know what? Let's just make this a little bit friendlier. So for the bill, we have those 6 y values, and for the brother, these 6 y values. And now we're going to go down and start answering some questions. Step 2, find the solution. So from the table, notice we're not finding it from the graph right now, we're finding it from the table, which this table can actually be graphed. What would, give me some ordered pairs from this table for Bill. Give me some ordered pairs that we could use to make Bill's graph. 321. Give me another one. 219. Give me another one. 015. Noah, give me another one. 525. Devontae, give me another one.
423.
423. There's one left that hasn't been used. Anybody know what it is?
117.
117, yeah. So we have 6 points right there. We go to a graph and make 6 points, draw a line for Bill's, to represent Bill's comic book collection, and then we also have 6 ordered pairs for his brother, don't we? Okay? Well, from the table, we're supposed to find a solution. How do you think we're going to find that solution in the table? How are you supposed to understand when what is the same? So where the y value is the same, the x value is the same. Okay, basically they each have the same x value and they both have the same y value. Where's that at in the table? 423. Okay, so right here, so we have at this spot, we can see that, okay, so find an x value, so x equals 4. That's what they wanted us to find right there. And then the same y value is 23. So find an x value for when the y value is the same. So What do you think would happen on a graph if we did graph this? What would happen on the graph? They would intersect. Where would they intersect at? Ordered pair 423, wouldn't they? This is really ordered pair 423 on a graph. That's where the two lines should intersect. That's where they should meet. It should be the only point they share in common. So now let's interpret that. What does that tell us? Use your answer to step 2 to find the number of months after which Bill and his brother have the same number of comic books. So, I think that what we can really do is we can go down and start drawing conclusions here. When will Bill and his brother have the same number of comic books in their collections?
In 4 months.
After 4 months, yeah. So let's write that. After 4 months, they will each have, and we're going to make this onto one sentence because there's one more question. How many books will each of them have? 23. They will each have 23 comic books. After 4 months, they will each have 23 comic books. Okay, so what I want you to do is now it says graph the equations on the back side. Let's make sure that it says what do you notice about the graph and the solution. Hopefully this is going to be what we just said should happen. They should intersect in order here 423. You can go back there and graph it whichever way you want. You can use the 6 ordered pairs that you have for each of them. After we keep looking back and forth. Or you could use what? The equations. Now, let's go to the back and see what that, what that graph looks like. Let's have a look at it and see how easy would it be to use the equations, okay? So, first of all, let's label our x and y axis because when we know what they're representing, we do that. What is the x-axis representing again? Months, the number of months. I've kind of started it for us, so we just have to fill in the blank here. And then the y-axis is representing what? The number of comic books. And after we have those labeled, then the next thing we have to do is we have to decide, especially when there are application problems, problem-solving problems, we don't always get to go by ones on both axes. What did I go by on the x-axis? I've already chosen the scale first. What did I choose?
Go by.
What's the x-axis going by? This is important for us to recognize. It's going by 2s. Every grid line is 2 months. Is every grid line 1 month?
Every other grid line is 1 month.
Yeah, every other is, so every grid line is actually a half a month, isn't it? Yeah, so half a month, a month and a half. So we are, we got to talk about the scale. I only started labeling the whole number of months, but the actual scale on it is going by half months. Okay. How about the y-axis? First of all, what does this mean, this little squiggly thing I did there? What is it? It's not starting from 0. I did a break in the graph. I scrunched up from 0 to 7 in that little area. So we don't count on the scale there. We start at 7, and we say there's our beginning grid line. The next grid line is what?
9 or 8 and then
8.
9.
So I am actually going by how many comic books at a time on the y-axis, Devante? How many comic books am I going by on the y-axis? At a time? 1. Even though I started at 7, it's still only going up by 1s, isn't it? So let's finish numbering it. Okay. So you always want to make it a nice reader-friendly graph before you even do any graphing. Okay, you have the option of using the 6 ordered pairs that we got in our table, or you have the option of using slope-intercept form. Well, let's see. If we did slope-intercept form, how friendly would that be? Okay, let's check it out. So m equals for, this is Bill, right? and this is the brother. Brother doesn't have a name, I guess. M equals what for Bill? 2. Some of you are already using the ordered pairs maybe, but I want to try and see if it's very friendly this way. How about the y-intercept for this one? 15. Okay, let's go see how friendly it is. We have to start at 15. We have to go up 2 books and over 1 month. Could we do that? Yeah, that wouldn't be so bad, would it? So we start at 15. We go up. This says, so this is really 2 over 1, and these are 2 books over 1 month. Remember, that's what we do with word problems. We identify what that slope is telling us. So it's really telling us to go 2 books for every 1 month. So we could go up 2 books, up to 17, and over 1 month, which is actually 2 grid lines, because each grid line is a half a month. Up 2 more books over another month. So in other words, we can't really go 2 up, 1 over. We have to go 2 up, 2 over to mean what's going on in this problem. And then we can draw our line. Now I'm going to guess they might possibly just turn out to be the points, those 6 points that we got in our table. Are they? I bet they are. Do we extend our line this way and put an arrow down here? Do we keep going down this direction?
No.
Why not? Because then we would have negative number of months and eventually negative number of comic books. So yeah, we don't want to go that direction. Okay, now let's do the brother using slope and y-intercept. See if we get the 7 points, 6 points that we had in our table. So now we're going to start at 7. And we're going to go, this means, so m equals 4. I got 4 over 1. 4 what? Books over 1 month. So now we go up 1, 2, 3, 4 books and over 1 month. So we're really going up 4 this time over 2, aren't we? Because if you don't want to have to make a table, we want to know how to do it this way also. Because you can make tables. I'm not saying there's anything wrong with that. It's just good to be able to not have to make one if we don't want to. And where are they intersecting? Right here, which is ordered pair 4. Go up, it's 4, and over is 23. And that's what we expected should happen, didn't we? Okay, now not only should we be able to use the graph to tell when they have the same number of books, how long did it take and how many books would they each have at that time, we should be able to also get some other information from our graph, like number 3a. How can you tell by looking at the graph when Bill has fewer books than his brother? Well, you know what I think would be helpful then? I think it would be good to call, their lines. This one is Bill. This one is Bill.
Isn't that the brother?
Oh, that is the brother. Thank you. Good job. Good catch. It is the brother's line. We don't want to say it's... this is the red one, yeah. This is the brother. This is Bro. And the other one is?
Bill.
Bill. Okay. So it's kind of nice to know which line is whose. Okay, so how can we tell by looking at the graph when Bill has fewer books than his brother? Joss?
Because the brother's line is steeper.
Okay, so the line is steeper. Okay, so when then in that steepness would we be saying that Bill has fewer books? Remember, books is on the what axis? The vertical or the horizontal?
Vertical.
Vertical, so up and down. So you gotta think up and down when you're thinking of number of books, right? So when on the graph could you say, oh, I can tell Bill has fewer books when Cody?
When Bill has 25 books, his brother will have 27 books. Because that's one of our equations that we had. It was 527 and 525.
Okay, that's kind of using our table though. How do we?
And the graph.
Well, I don't see
You didn't see
527 on that graph, not mine.
That's because you go to 26 and then it's 27.
So it's kind of like off the grid,
Yeah.
but it's up there. Okay, well, so, yeah, tell me more. How can we tell by looking at the graph?
Bill's line is less steep than his brother's, so his brother will eventually have more books than Bill.
Okay,
Bill's brother's slope is more than Bill's slope,
yeah, that's true.
which means it's gonna rise faster.
Which means it rises faster. Okay, so does that mean since it rises faster, his brother always has more books than Bill?
After 4 months.
But not till after 4 months. So when we look at the graph, can't we say, is this the part right here when Bill has fewer books than his brother? That's the part right there. So on the part of the graph where the line is what? Bill's line is below the brother's line. Isn't that what's happening here? Isn't it below it? Okay, so let's, looking at the graph, let's talk about, you know
Wait a
what?
second, I just noticed something.
Okay,
For the y equals 2x plus 15, we did, plus 2 and over 2, we went up 2 and over 2.
okay, but remember why? Because when we have to go over 1 month, to go over 1 month, you have, this is only a half a month, so I have to do 2 over. Okay. But yeah, that's, you gotta make sure that we are doing it right. So when we're looking at the graph, Bill's line is below his brother's line. When he has fewer books. And yes, that's after 4 months, isn't it? So in other words, when did he have more than his brother?
At first.
At first, because his line was above his brother's then. This is showing less books here, so his line is above it. So before 4 months, the brother was in the lead. Bill was in the lead, excuse me. Bill was in the lead in the beginning. Then at 4 months, his brother caught up to him. And after 4 months, his brother took over. He had more books. Will he always have more books after 4 months?
Yes.
The brother?
Yes, he will.
Why?
Because his line is steeper than Bill's.
Now, that's when we can talk about steepness. It can never catch up to him, can it? Yes, Cody?
Oh, my graph. My thing shows the table we have.
Yeah.
Two is much needed.
Okay, and does Bill ever catch up to his brother again in that table, Cody? No, he can't, because his line is steeper, and once he caught up to him, he's gonna rise and run faster. That's when we would say the steepness, comes into play at that point. So how can you tell when the brother has fewer books than Bill?
After 4 months.
When-
Before 4 months.
Before 4 months, when his line is,
Steeper.
so his line is below, so the brother's line, oh, I should use the word the in front of that makes a whole lot more sense, not brother's line. The brother's line is below Bill's line when he has fewer books. You know what, let's do what we were saying, and we didn't put it up here, but we will. Bill's line is below his brother's, and we're gonna say after 4 months. And the brother is up to 4 months. So Bill gets to brag, and he's got more comic books, up until 4 months. But then at 4 months, he can't brag either because now they have the same amount. But after 4 months, he better not be bragging about having more comic books either because his line now went below the other one and he does have fewer books. Okay, so anybody have any questions about, first of all, one of the most important things about this is you have to know how to set up your own equations properly to help you get good answers to the problems that you're solving. So anybody unclear about being able to set up those equations correctly? Pardon? No questions? Okay, then I will get your worksheet out to you. And make sure you read what it is that they're asking you to do. And if you don't read, you're going to leave out some of the steps and then I'm not going to stamp it. So you make sure you know, sometimes it might ask you to write equations, other times it might not. But make sure you read to find out when it does. And make sure you do that part also. Not just graph from the information given. Because we could have graphed this very easily with just the information given and not written equations. But it's important that we know how to write those also.